Okay, this lesson is going to be all about dividing polynomials, and we go from very simple ratios to a much more complex long division. So I really recommend that you write down the problem first, pause me, okay, pause the video, write down the problem, see if you can solve it, and then check it with me because I know I work fast. And I don't feel like that always gives you a chance to challenge your brain and, teach yourself. But at the same time, I can't make the video slow. So pause. Okay. All right. So first we're going to do dividing a polynomial by a monomial. Okay. In one variable. So taking a look at this one. Okay. It's really pretty simple. This is going back to fractions. If you had something like 3 plus 6 over 3. Okay, you can tell that's going to be 3, right? Because 3 plus 6 is 9. 9 divided by 3 is 3. I don't know if you guys remember, but you can separate this into two different fractions. You can separate it into the first and the second one. So that's going to be 1 plus 2, which equals 3. That is a rule. A plus B over C is equal to A over C plus B over C. And we're going to use that a lot here. Okay, because what we're going to do is rewrite this as 13x cubed divided by 2x plus 6x squared divided by 2x plus 10x divided by 2x. And now we're just looking for common factors. There's nothing that goes into 13 and 2, so we're just going to rewrite that. 13 halves. Now there's 3 x's on the top, 1 on the bottom. We're left with 2 on the top, x squared. There's 2 on the top, 1 on the bottom here. 6 divided by 2 is 3. You don't need to put the 1 on the bottom, okay? And look, 2 goes into 6 3 times. X goes into x squared x times. We don't even need this line here, okay? Because we got rid of the whole denominator. And here, 2 goes into 10 5 times. X goes into x, okay? Now you could actually show that. By the way, don't exit. Don't go right, go left, go straight down like that. This is the way we show it if you're going to do that. 3. Okay. 2 goes into 10, 5. X goes into, there's 2 left over. And that's how you would show it. Be careful with that. Notation can get really ugly sometimes. All right, moving on. All right, let's take a look at this one. Separate it out. 2x to the 5th negative x squared plus 4x squared over negative x squared. So that's a little weird. Seeing the negative in the denominator is just funky to me. They just do that to throw everybody off. So a positive divided by a negative. I'm trying to write a positive here. Positive. Oh my God, that's ugly. Blech. Okay, let's try again. Positive divided by negative is a negative. Okay, there's nothing to do with the 2, so we have to leave it. There's x squared on the bottom, x to the 5th. So there's 2 on the bottom. There's 3 left on the top. Or 5 minus 2 is 3. Okay, minus 4, right? Because positive 4 divided by negative 1, if you want to put a 1 there, you can, always, is negative 4. And then x squared and x squared cancel. And that's your answer. Okay, next. Same thing. Okay, same thing, longer. So we get 19b to the 5th over 4b cubed plus 12b to the 4th over 4b cubed plus 8b cubed over 4b cubed. Now would be a good time to pause it. Okay, and now we're going to go. 19 fourths, nothing you could do there. B cubed goes into b fifth, b squared. There you go. Plus 4 goes into 12 3 times, so 3 b cubed. 4 minus 3 is 1. 1 left over. These cancel, and you get 8 divided by 4, 2. And that's your answer. Okay. You have a fraction here. Don't worry. That's totally fine. You can have a fraction here. It's okay. Okay, what's most important is that you separate it out. Okay, now we're going to get into polynomial long division. So I am going to add a page in here. Okay, because I want to remind you of long division. I bet you guys haven't done long division in a while. So here we go. Let's say you have 846 divided by 2. How do you do long division? First, you start and you go, okay, I'm going to look at 2 and I'm going to look at that first one. 2 goes into 8 4 times, right? And then you multiply 4 times 2 is 8. And then you subtract and you get 0, right? And then you bring down the 4. And then you go 2 goes into 4, okay? Well, you bring down the 4. 2 goes into 4, 2 times. 2 times 2, 4. Subtract the 4, 0. Bring down the 6. Then you say 2 goes into 6. How many times? 3. Okay. So 2 times, then 2 times 3 is 6. You subtract and you get 0. Then you have a 0 remainder. Okay. I'm going to do another one. Let's say you have 439 divided by 3. You go 3 goes into 4 one time. 1 times 3, 3. Subtract 1. Bring down the 3. 3 goes into 13 4 times. 4 times 3 is 12. 13, 3 minus 2 is 1, right? Bring down the 9. 3 goes into 19 6 times. 3 times 6 is 18. And you get 1 remaining. Now, when you were really little, you would put remainder 1, and we're going to do that today with polynomials. Okay? And then when you got a little older, you got to say this. 146 and 1/3. Or we could even say 146 plus 1/3, right? We are going to use all these two forms today with polynomials. Okay? When you have a remainder, you can either add it or you can just put remainder. So I wanted you to remember the process of long division. You look at the first and you go, how many times does that go in there? Once. Then you multiply this and you put it there. Then you subtract and you bring down. Okay, the process is going to be the same for long division with polynomials. I am going to teach you a quicker version, but you're kind of still expected to know how to do this. 2x, ooh, sorry about that. Got my hand on there or something. 2x plus 3. Okay, so this is, you know what? No, I'm not going to write it there. Nope. Forward. Okay, so I am going to write it up here. Stop it. Stupid computer. Okay, so 2x plus 3 into 4x squared plus 20x plus 21. Now they always throw in a kink, you guys. Do you see like how it goes squared? Okay, there's a square term, then there's to the first power, and then there's to the basically x to the 0, which is 1. Okay, 2, 1, 0. It's nice and ordered. So is this one, x there. So if they somehow skip one of these, sometimes, like in other words, what if they asked you to just do 2x plus 3 into 4x squared plus 21? Like they eliminated that. You have to put a 0. I'm hoping we hit one of those today. If not, I'll make one up. Okay. So how do we do this with polynomials? It's a little funky, but it's the same process. You look at the first term of each. That's it. And we don't care about the 3 and we don't care about that crap. All we care about is the 2x and the 4x. And we go 4x squared. And we say, how many times does 2x go into 4x squared? So basically you're thinking of this. 4x squared divided by 2x. How many times does it go in there? And the answer is 2x. Okay, so you're going to go 2x. Why? because 4x squared divided by 2x, okay, 2 goes in there, 2x goes in there, is 2x. Okay, I actually don't think of it as division. I think of it as multiplication, like 2 times 2 is 4, x times x is x squared. But it's up to you. Now we multiply. 2x times 2x is 4x squared. Okay, subtract, and you're going to get 0x squared, and then you're going to bring down the 20x. Okay, bring this down. Then you say, how many times does 2x go into 20x? So you're thinking like this, 20x divided by 2x. The answer is 10. So it goes in there 10 times. Then, oops, I made a mistake. You guys, I made a mistake back here. Sorry, I got all excited and I forgot to multiply the second term. So when we multiply the 2x, we go 2x here and we get 4x squared. Then you have to multiply the 2x times the 3. So you get plus 6x. My bad. I will fix that in the next problem. I apologize. So here's the tricky part. This is the most dangerous part of the whole problem. You see this minus sign out here? It doesn't mean just these guys. It means this one as well. So my recommendation is this. So you don't make this mistake. And trust me, I've seen enough kids do this that it's a huge issue. My recommendation is put parentheses around that and then distribute that and change it to an adding problem. So you go plus negative 4, negative 6x. And then you have 4 minus 4 is 0. 20 minus 6 is 14x. Okay, let's get rid of that 10. Then you ask, how many times does 2 go into 14? And x. How many times does 2x go into 14x? So that's 14x divided by 2x is what you're thinking. And the answer is 7. So you go plus 7. Then you're going to distribute this. 7 times 2x, 14x. Oh, yes. Bring down the 21. Same thing. Okay. Plus 21. And look, there's 0 remainder. So the answer is 2x plus 7. I don't know if you guys can appreciate this, but this is what it's really saying. It's saying that 2x plus 3, right here, times 2x plus 7 is equal to 4x squared plus 20x plus 21. Think about it this way. If I take 12 and I divide it by 4, I get 3. What does that mean? 3 times 4 equals 12. In the same way, I divided this polynomial by this binomial. I got this binomial, and that means these two things multiply together to get back to that one. It's a big concept. All right, I'm going to try to do this one a lot better. I didn't do that one very well. That kind of sucked. Okay, 20x plus 20. Okay, so this is kind of pretty. Look at x squared, x down, x minus 5. Okay, so we're going to look at just the first term of each of these polynomials. Okay, x goes into 3x squared how many times? Or I think of it as x times what is 3x squared? 3x. And you can come over here and just do this on the side if you need it to. 3x squared divided by x, and you get 3x, okay? Then you distribute. 3x times x is 3x squared. If they match, you know you did it right. 3x times negative 5 is negative 15x. Now here's the danger zone. Danger. Because we're subtracting. So I'm going to change this to an addition. Add the opposite. Okay, change this to an addition and change the signs. Yes, you can say negative 20 minus negative 15 is negative 20 plus 15, but that's a little harder. Okay, these are going to cancel. And you're going to get negative 5x because negative 20 plus 15. Then bring down the 20. And now ask yourself, how many times does x go into negative 5x? So negative 5x divided by x is negative 5. Distribute. Negative 5x plus 25. And then we have 45 remainder. So it says your answer should give the quotient and the remainder. So your answer is going to be 3x minus 5, remainder 45 over x minus 5. I think that's the way they're going to want it. You take this number over this number. Okay? The answer would be 3x minus 5, remainder 45 over x minus 5. Now, they might just ask for the remainder. Like, what's the remainder? But this is really the remainder, the whole thing. So I'm not sure how they're going to ask for it, but that's what it should be. Okay? Next. Let's take a look at this one. Let me do this one, did I? Yeah, it's the same problem. Moving on. Okay, here's a different type. Okay, how is it different? It's a cubic. Cubic divided by, to the first power. It's just a little longer problem. That's really all it is. So I'm going to go down here. 6x cubed minus 11x squared plus 16x minus 3 divided by 2x minus 1. Okay, so now we're going to look at the first term. Okay, here 2x times what equals 6x cubed? That's how I think of it. I think of it forward with multiplication. You can always think of it backward as 6x cubed divided by 2x, and then get the answer 3x squared. Then you multiply 3x squared times 2x, 6x cubed. 3x squared times negative 1 minus 3x squared. Now we need to add the opposite, change the signs. Okay, that looks like a weird sign. I don't know what that is. Don't leave that. Okay, so we're going to subtract this quantity, right? Which means we are going to add the opposite. Then we come down, we add them, cancels, and then we're going to get 8x squared negative, because 11 is negative, plus 16x. Then we ask our question, how many times does 2x go into negative 8x squared? So again, you can go like this and figure it out, or you can ask yourself 2x times what equals negative 8x squared? Answer is negative 4x. Because 4 times 2 is 8, x times x is x squared. Okay, then we're going to multiply these. And you're going to get 8x squared minus, okay, and next one is positive 4x. And now we're going to subtract this quantity, which means we are going to add the opposite. So this becomes 12x. And these cancel. And then you ask yourself, 2x. How many times does 2x go into 12x? And the answer is plus 6. Bring down the negative 3, by the way. Okay, so 12x minus 3. Then we distribute that 6. And I had 12x minus 3. And I'm going to distribute, and I'm going to get 12x minus 6. And then we subtract this quantity, which means we add the opposite. Okay, and then these cancel, and you get 3. So the remainder is 3 over 2x minus 1. I think that's how they're going to want it. You guys can let me know. Okay, next. Again, another problem. The only reason I'm doing so many is because these are actually kind of intimidating to kids because it requires a lot of organization and faith that, yes, it's going to work out. I'm telling you, the parentheses thing, when you subtract, is probably critical. It's super easy to lose your place here. It really is. This can get a little rough. So 3x, just look at the first term. 3 times what is 9? 3 times 3 is 9. X times what is x cubed? X squared. Again, you can go over there and divide 9x cubed divided by 3x. Multiply it out, distribute. 9x cubed minus 9x squared. And then we are going to subtract that quantity, which means we come back and we add the opposite. So these cancel, and then that becomes negative 11. Is that right? No, that gives me to 20. 12. Negative 12x squared. Then you go 3 times what is 12? Negative 12. Negative 4x, because x times x is x squared. Or again, go over here, negative 12x squared divided by 3x and figure it out. Okay? And then you multiply, distribute it out. So we get negative 4. Oh, wait, I got to bring down my 3x too. And then I get negative 4. 4. Oh, what am I doing? Then I get 4 times 3 is negative 12x squared. X times x is x squared. Negative 4 times negative 3 is positive 12x. We are going to subtract this quantity, which means we add the opposite. These cancel because they're opposite, so we get negative 9x. Bring down the 7 plus 7. How many times does 3 go into negative 9x? Minus 3. 3 times 3x is negative 9x. Negative 3 times 3x is negative 9x. Negative 3 times positive 3 plus 9. But remember, we are subtracting this quantity, which means we add the opposite, and we get minus 2. So the remainder is negative 2 over 3x minus 3. All right. Again, I'm still not sure how they're going to put that remainder. Okay, another one. Wait, is it the same one? Sorry, I grabbed these twice. Okay, let's take a look at this one. This one says to put the remainder like we did last time. I've been putting it like that, so I'm not sure if the other remainder would be just putting the remainder. It might be. So here we go. Okay, nope, I'll go forward. Okay, so here we go. Negative 3x to the 4th plus 9x cubed plus 11x squared minus 5x plus 6. We are going to be dividing that by, get rid of this blue, y'all. I'm going to be dividing that by negative 3x squared minus 1. Now, why is this different? I guess because of the negative in the front. Okay, but it's not really that different. I really wanted them to hit me with, and it's hard to find it, but without one of these terms. Yeah, where you have to put 0 in. If we don't hit it, I'll make sure I'll give you one. Okay, looking at the first term. Negative 3 times 1 would be negative 3, right? X squared times x squared is going to get us to negative 3x to the 4th. Yeah? So negative 3x to the 4th divided by negative 3x squared is x squared. Multiply, and you get negative 3x to the 4th minus x. Oh, here it is. Well, here's one of them. Minus x squared. And then you're like, oh, crap, look. These don't match. That's okay. Don't make them match. Put it where it belongs. Minus x squared. Okay, but remember, we are subtracting this quantity, which means we are going to, right? We're subtracting this quantity. Okay, which means we are going to be changing the signs, adding the opposite. Okay, instead of subtracting, we'll be adding by adding the opposite. So these cancel. We'll bring down the 9x cubed plus 12x squared. Okay, now ask yourself, 3x squared goes into 9x cubed how many times? Negative 3. 3 times 3 is positive 9. X, because x times x squared is x cubed. Okay, again, go around the side and divide. So then we get 9x cubed distributing plus 3x. And look, it doesn't match again. You're like, crap, it isn't where it goes. It goes over here. Okay, and again, we're subtracting this quantity. So we're going to add the opposite, change the signs. So this becomes, cancels. You get 12x squared minus 8x. Negative 3x squared goes into 12x squared minus 4 times. Negative 4 times negative 3 is negative 12x squared. Gosh, I'm barely making it. Plus 4. We're going to put the 4 over here. We're going to bring down the 6. Plus 6. All right, so we end up with this. You guys will be better because you have your papers. 12x squared minus 8x. We bring down the 6 plus 6. And then we get negative 12x squared plus 4. But remember, we are subtracting that quantity. So we're going to add. Ooh. Did I make a mistake? I want it to be positive. Oh, that was positive. I screwed up. Yeah, it was positive already. It was positive. Negative times negative is a positive. So that becomes a negative. We're subtracting, and that becomes negative. Or you could just say 12x squared minus 12x squared is 0. Negative 8x, 6 minus 4 is 2. And then we're done. And that is the answer. Okay. Okay, so does this get a little tricky? Yeah, it does. Okay, because we have all these negative signs. I am hoping that Alex allows you to plug it in like this. Okay? It is a little crazy because if we consider the signs, we could factor out a negative on the top. See, but we're not factoring yet. So I don't think we should have to do that yet. I'm going to go ahead and finish it just in case. And then it would become plus that. Okay, I honestly don't know how Alex is going to do that. This is what I ended up with, this. This negative over negative is a little funky, but you can't just cancel them. That doesn't work that way. You can't do that. I factored out a negative here, and I factored out a negative on the bottom. And I ended up with that, but I don't believe we've learned that yet. So I'm not sure how Alex is going to reconcile that with you. Yeah, I'm not sure. I feel like they should do this. I'm going to need to talk to some of you guys as you go through this. You're going to have to talk to me, I suppose. Okay, so here we get one weird one like this. And these are the ones that really trip up kids because you get all happy doing your little, like, okay, in your mode and you're just working along. But look what happened. First of all, this is a square and it's missing an X term. This one is completely out of order. You must put it in order and then look. It's missing a square term. You have to put in the 0 for the square term. If you don't put in the 0, you will get the wrong answer. So do you see what I did? I had to put the 0 in. I had to put it in standard form, decreasing order of exponents, and I had to put this one. Now I don't need to put the 0 here, but I could. It wouldn't hurt. It might be kind of nice even, because then we wouldn't have such issues with lining things up. Let's go. 5x squared goes into 15x cubed. How many times? 3x. Distribute. 3x times 5x squared is 15x cubed. 3x times negative 3 is negative 9x. See? You know what? I'm going to try that. I have never done this before. I'm going to try it. What if I put 5x squared plus 0x. I think that's going to make my life a heck of a whole lot easier. Ready? Here goes. So we distribute. We get 15x cubed, and then we get 0x squared minus 9x. I guess it just it kind of held its own place. Okay, again, we're subtracting, which means we change the signs and we're adding, right? Add the opposite. Okay, these cancel, and we're going to get negative 10x. Bring down the 3, minus 3. Okay, and guess what? You're done. Because look, this is a square, and that's a 1. Squares don't go into 1. You're good to go. So you're going to go 3x plus negative 10x minus 3 over 5x squared minus 3. You just put what was out here, which is 5x squared minus 3, and you put this on top of it and put a plus sign right there. And you should be good to go. All right. Synthetic division. Get out of here. Get out of here. Why is it doing this, y'all? Okay. Okay, last thing. This is kind of a big thing, and it's going to be super big in the next unit. And I don't understand how they put their notation. So here's my thought. It says use synthetic division to find the quotient remainder when blah, 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 blah is divided by that. Specifically, complete the synthetic division table below and write your answer in the following form. Quotient, which is your answer, plus remainder over x plus 3. All right. So I think what they've done is taken out the x's, okay? And they've only written the coefficients. So notice 2, negative 1 is right here. Negative 18 is right here. 12 is right here. 9 is right here. And instead of 3, they put minus 3. The reason why they put minus 3 is because, well, I can't actually explain it to you right now, but that's what we do. Because that's going to make this 0, and it's too much of a complex issue to deal with now. Okay, what you do is you take the opposite. Okay, you put the opposite on the outside. Okay, opposite of positive 3 is negative 3. That's where they got that one from, the denominator. All right, and then you go like this. You ready? It's kind of fun. You bring down the 2, and then you say negative 3 times 2, you multiply, and you get negative 6. And then you add, and you get negative 7. Then you multiply, and you get positive 21. And then you add, and you get 3. And then you multiply, you get negative 9. Holy crap, I hit it with my thumb. Do that. Yikes. Where's division? I can't find division. I'm sorry about this, y'all. I don't know what the heck is happening. Division. Algebra 2. Algebra 2. Oh. Oh my God. You guys, let's go on a trip with Miss Baca down the Jamboard lane. Here we go, right there. Okay. Wow, that was crazy. Was that crazy or was that crazy? Okay, let's do this. There's synthetic division. Okay, so you go 18, negative 18, 20 plus 21 is 3. Multiply, negative. Okay. Negative 9, negative 9. And then add, and you're going to get positive 3. Okay. And then you multiply, and you get negative 9, and you got 0. Yay. So the answer here is going to be, now get this, it's going to be weird, y'all. we are going to use these numbers here, okay? And we are going to drop down these numbers, 2, 7, 3, 3, 0. We are going to drop down one level. Like we started with 4. So the answer is going to be 2x to the third. We dropped down one level because we divided it by x to the first. Okay? Plus 7x squared minus, oh wait, no. Sorry. Yeah, no, it was plus 7x, but not there. Okay, and then look, it's plus 3x plus 3 plus 0 over x plus 3. Okay, so what you do is you basically bring down the number, multiply, add, multiply, add, multiply, add, multiply, add. Okay, this is your remainder. Whatever's here is the remainder. Okay, the other thing that's critically important is to realize that if you're dividing x to the fourth by a power of x to the first, whatever comes after, who cares? By power of x to the fourth, this is automatically going to be dropped down 1 degree because 4 divided by 1 is 3, right? Got to cancel one of those. Can't cancel it like for real in your head, but I mean, that's the way it works. All right, this is your answer. Let's try to do another one. I have never seen this done this way, so it's kind of a little bit of a learning experience for me, y'all. Here we go. I'm actually going to change this so that I can see it better. Okay, now notice they did x cubed, so 1x cubed, but we're missing the x squared term, so we're going to put a 0. Then we're going to put minus 22, and then we're going to put plus 15. All of the coefficients, that's what goes in here. The opposite of whatever's here goes outside. Then we go like this. We bring this number down, 1. We multiply, -5. And we add, -5. Then we multiply. -5 is positive 25. Then we add 3. Then we multiply, -15. And I got a 0. This number here is the coefficient to the degree below. So x squared minus 5x. Take it down 1. I didn't touch it. Go away.